Hi everyone. So in this video, we're going to go ahead and talk about Gay-Lussac's law. Hi everyone. So in this video, we're going to go ahead and talk about Gay-Lussac's law. So Gay-Lussac's law tells us that pressure and temperature are proportional when volume and the number of moles are being held constant. So said another way, when the temperature increases, the pressure is also going to increase and vice versa. So if we cool objects down, the pressure will also decrease. So if we go ahead and graph this phenomenon, we get a nice linear line going between pressure and temperature. So if we go ahead and graph this phenomenon, we get a nice linear relationship between pressure and temperature. Now the equation for Gay-Lussac's law is P1 over T1 equals P2 over T2. And a really important thing to remember, temperature is going to be in Kelvin. So if you're given the value in Celsius, remember to add that 273. So P stands for pressure, T again for temperature in Kelvin. The ones are the initial values and twos are the final values. So a real life example of this is tire pressure in your car. So as you start driving, originally your tires are cool, so the pressure is lower, but as you start driving, you get more friction buildup, which heats up your tires, and the pressure inside your tires will increase over time. In the lab, they had the example of the beaker with the candle. So when the candle was extinguished, that cooled the air down in that beaker slightly, which had the pressure decrease. So then the water was able to flow into the beaker due to the lower pressure. So let's go ahead and try out some mathematical examples. Okay, so let's go ahead and try some examples of Gay-Lussac's law. So as we see, the equation for Gay-Lussac's law is P1 over T1 equals P2 over T2. Ones are the initial values, twos are the final values. P, remember, stands for our pressure. And that we can be pretty flexible in with what units we use as long as it's the same unit on both sides. T2 is going to be our temperature. And a key thing here, remember, we have to have units of Kelvin. Okay, so we're going to need to convert by adding 273 if we're in degrees Celsius. Okay, so let's go ahead and try out an example. A 20-liter cylinder contains 6 atmospheres of gas at 27 degrees Celsius. What would the pressure of the gas be if the gas was heated to 77 degrees Celsius? Okay, so as I read through this problem, I see that they're giving me some extra information. So they tell me the size or the volume of the container, but I don't need it because that's not changing at all. All that is changing is the pressure and the temperature. So I'm going to go ahead and cross that off just so I don't confuse myself and accidentally use it later. Otherwise, we're going to look for those paired values. So 6 atmospheres of gas at 27 degrees Celsius. That's going to be our initial set of values. So P1 is equal to 6 atmospheres. T1 is equal to 27 degrees Celsius. And then for our final, our twos, P2, that is our unknown. That's what we're solving for. And then our T2, that is going to be our final temperature, which is 77 degrees Celsius. Now, in this case, I do have Celsius and not Kelvin. So I'm going to go ahead and add 273 to both of those values to get their counterpart in Kelvin. Okay, so 27 plus 273, that gives me 300 Kelvin. And 77 plus 273, that gives me 350 Kelvin. Okay, so let's go ahead and plug these values into our equation. So we have P1, which is 6 atmospheres, over T1, which is 300 Kelvin. And that is equal to our P2, our unknown, divided by our final temperature, which is 350 Kelvin. So if we pause here for a second and think about this, temperature is increasing. Therefore, we expect the pressure is also going to be a little bit higher once we raise the temperature. Let's go ahead and prove it mathematically. So we're going to go ahead, multiply both sides by 350 Kelvin to get P2 by itself. So if I go ahead and rewrite that, my units of Kelvin disappear because I have them on the top and the bottom. So now I just need to go ahead and plug this into my calculator. So 350 times 6 divided by 300. So that gives me a value of exactly 7. Okay, and in this case, that is a good answer because we only have one sig fig in the value of 6 atmospheres. So that would be our answer, which is what we predicted, that the pressure would increase slightly. Okay, so the next one, I want you to go ahead and try this one by yourself. The pressure in a car tire is 1.8 atmospheres at 25 degrees Celsius. What will the pressure be if the temperature warms up to 37 degrees Celsius? So go ahead, pause this video, try it on your own, and then come back and we'll go over the answer together. Okay, so for our paired values, we have 1.88 atmospheres at 25.0 degrees Celsius. So that is going to be our set of ones. So our initial pressure is 1.88 atmospheres. Our initial temperature is 25.0 degrees Celsius, which we will have to add 273 to convert to Kelvin. So that gives us 298 Kelvin. And then we have our final temperature, which is 37.0 degrees Celsius. Again, we add that 273 to that number. So that gives us 310 Kelvin. And our P2 is our unknown. That's what we are solving for. So let's go ahead and plug these values into our equation. So we have 1.88 atmospheres divided by our initial temperature in Kelvin is 298 K, which is equal to P2, we do not know, divided by 310 Kelvin. So again, our temperature is increasing, so we would expect that our pressure will increase as well. So in order to get the P2 by itself, I'm going to multiply both sides by 310 Kelvin. So I go ahead and rewrite that. P2 is equal to 310 Kelvin times 1.88 atmospheres divided by 298 Kelvin. So our Kelvins cancel, leaving us with atmospheres, which is good because we want a unit per pressure. So if I plug this into our calculator, 310 times 1.88 divided by 298 gives me 1.955. Okay, so 1.95570. Okay, but we do want to think about sig figs. Remember, we want to go to the least smallest number of sig figs. So we have 3 sig figs here, 3 here, and 3 here. So we want 3 sig figs in our final answer. So we are going to chop it off after the first 5. But since we have a 5 following, means we round it up. So our P2 is going to be 1.96 atmospheres. Okay, so I hope that helps. If you have any questions, please let me know. Otherwise, have a great day, everyone. Bye.